Yeah, hello. Yeah, so today let us look at some data description, okay? Performing some simple statistical summaries in R, okay? Yeah, so what we are going to do is, first of all, let us try to set our working directory, okay? So we look for the location of our data, and then we copy the location link. So the data we are going to use is the iris data, which is made available for you on Canvas, okay? Now, so what you are going to do is, and this particular data have been created to have some missing information, okay? Yeah, so let us look at, so you go and then you copy the working directory, and then you come here, you put it in the close brackets, the quotation marks, okay? And then you change all of them to the / to the backslash to /, okay? Okay, let's see. Yeah, so you change all the backslash to /. Now let us run it. Okay, so now we've set our working directory. So now let us go ahead and then try to load the data set, okay? So what I'm going to call it, I'm going to call it iris. Let's say underscore data. That's what I'm going to call it. That's how I'm assigning the data. So we are using, it's a CSV file, so we are going to use the read.csv, okay? And then the data, the data is called iris, and it is a CSV data. So what we are going to do is, so with a close quotation, we are going to say iris.csv, okay? And then you say header to ensure that it gives us the head of the data, okay? I go through, okay? All right, so let us go ahead and then run it to load the data. Okay, so the data have been loaded. So for instance, you might want to know what is the head of the data. So iris underscore data, you'll be able to know the head of the data, which is, it gives us, or even you might want to know the names, right? The names of the data, which is iris underscore data, okay? So that gives us the names of the columns of the data set, okay? So now we can perform a simple summary of all the variables within the data set or all the columns, okay? So iris underscore data. So now you can see we have some NS in the data set. So let us see how, before we perform any further statistical summaries, let us look at eliminating the NS, okay? So we have I'm going to give a new name, which is called clean underscore iris data, iris underscore data, okay? And then that would be, I'm going to use the function called na.omit, okay? And that is allow us to be able to omit any missing information, okay? Any row that has missing information is going to be deleted. So now the original data is the iris underscore data, okay? So now let me run it. Okay. So now once I run it, I'm able to, we can check whether have we been able to omit all the missing information, okay? By just again performing the same summary, the statistical summary, okay? the summary of the clean data, okay? And then let us look at it. So you can see now there is no NAs as compared to before where we have NA. So now the data have been clean. Now, what if we are interested in looking at statistical summary of the entire data frame? Okay. So first of all, let us look at performing individual, statistical summary. So our statistical summary for the entire data frame is when we can use the summary of the clean data. Okay, that's exactly what I did up there. Now let us look at calculating individual summaries. Okay, so something like average. So average, we use a function called the mean function, and then we are going to use the mean function to calculate what? The iris data. Okay, but then we want to actually perform it. You cannot perform the mean function on the entire data frame. You have to perform the mean function on a particular variable within the data set, okay? So what you can do is you can use the $, then now that allow you to be able to pull up the variable and then perform the function, which is the mean function. So we want to perform the mean function of peta, the mean function of peta length, okay? So this is the mean of peta length. But the issue is now we wouldn't want to always go ahead and be using the $, to call the data, right? So what we can easily do is we can go ahead and attach our clean data. We can attach the clean data. Now, once we attach the clean data, what then it means is that we don't always have to use the $. So now we can just say that give us the mean of, for instance, let's say the mean of separ length, okay, or separ width. So separ width. So here is it, and then we can perform the mean. So this is the mean of the separ width, okay. Now, what if we are interested in the middle number? Okay, the middle number is finding the median, okay. So we can say the median of the separ width, okay. So median of the what is separ width. And then so the median of the separ width is 3. Okay. Now, what if we are looking for, so sometimes you might want to know the value which is most frequently occurring within a particular variable, right? So that way you have to be able to find the mode. Now, the way in which you can actually find the mode is to use a statistical package, which is called the MODIS, okay? So first of all, you have to install it, and then you have to use the library, okay? So I have already installed it, so now I can use the library to load or activate that particular package. So now I can go ahead. The package is called the MFV. So the MFV. So the MFV of what? Let us look at the MFV of separ width. Okay. So we would want to know what is the mode or frequently occurring value within the separ width. Okay. So now we can go ahead, and that is what? That is 3. 3 is the most frequently occurring variable in the separ width. Okay. We can do the same thing for maybe the separ length. So, MFV of the separ length. Okay, let's see, which is 5.1. So, which is 5.1 is the most frequently occurring value within the separ length. Okay. Now we can also go ahead and then find some values such as standard deviation, right? Standard deviation. So we can use what is called the SD function. Okay, so standard deviation is we want to find the standard deviation of the cell per width. Okay, so we can go ahead and then find standard deviation of the cell per width. So standard deviation measure the dispersion of the data or how spread the data is. So we have the standard deviation of the cell per width to go at 0.4418. Yeah. Now we can also compute the variance. Okay. So the variance is using the var of what? Let's say we want to pursue the variance of cell per weight. So again, cell per weight, and then let's run it, and that gives us what? 0.195. Now remember that the square of the standard deviation gives us the variance, right? And then we might want to know the range. Okay, the range means looking at the minimum and then the maximum data, okay, or value within a particular data. So we can look at the range. Let's say, what are we looking at? We want to look at the range of cell per weight, okay? So we use the range function, and then we run, and that gives us, so this is the range. So we have 2.0 as the minimum, and then 4.4 as the maximum within the cell per weight. Then we can also find the interquartile range, which is the IQR, which is the difference between the maximum and then the minimum, right? So that's the interquartile range, which is actually giving the differences between the first and then the third quartile within the data set, okay? Yeah. So now we can go ahead and then use the function, which is called the IQR function, okay? So the IQR function also helps us to be able to find the differences between the first and then the third quartile of cell per weight. Let's look at it. Okay, so the IQR is what? It's 0.6. Now we can also find the quantile. Okay, the quantile actually gives us some specific quartiles. Okay, so remember I made mention of the first quartile and then the second quartile. Okay, so we can actually use what is called the quantile function. So this is the quantile function, the quantile of, let's say, the cell per weight. So this gives us we have the first quartile, we have the minimum, the 0% is the minimum. We have the first quartile, which is 25 percentile of the data. The middle or the median is the 50th percentile. We have the third quartile, which is the 75 percentile. And then we have the maximum, which is the 100 percentile, right? Yeah. Okay, so now we can also do some kind of manipulation in terms of how we find some of this summary, right? So for instance, we will be able to use what is called the supply function, okay, and apply it to a particular variable within our data set, okay? So how do we go about it? So we can use, for instance, if we want to, let's get the name of the data again, the names. Okay, so we have the head of the data, the head of clean iris. Okay, let's just look at the head of the data. Okay, so so we have 1, 2, 3, 4, 5. The fifth variable is a categorical variable, right? Which is currently in character. Okay, so let us exclude the fifth variable and then now compute the mean for each of the remaining column, which are continuous variables. Okay, and that's using the supply function. Okay, so what we can do, we can say that, okay, supply. Okay, now it is asking us to actually look at what actually do we want to find. Okay, so first of all, we would want to find the supply of, let's look at the clean underscore iris data, okay? So clean underscore the iris data. Underscore data, okay? Now what we are going to do is we are going to be able to exclude the column 5, which is categorical variable, okay? And then the function, what function do we want to compute? We want to compute the mean for all the columns, okay? So the mean for all the columns, okay? So now this is what we have. So we can go ahead and then let's run it, okay? So now it gives us the mean for all the 4 remaining columns. So it eliminated column 5 and then give us the mean of the continuous variable within the data set, okay? Now we can do the same thing if you want to find the quantiles, okay? So we can just copy and paste here, and then let's, instead of the mean, we want to look at the quantile, and let's run it, okay? So now it's able to give us from the maximum, from the minimum to the maximum, that the minimum, the first quarter, the median, the third quarter, and then the maximum value of the data, right? Okay, so this is how you can actually use the supply function to be able to also get the statistical summary, okay, or some descriptive from your data set. Okay, so now what if we are actually interested in grouping this description of the data, okay? So you want to perform a descriptive statistics and then you group it by a particular, let's say categories, okay? So what we can do is, so for instance, let's say we are interested in finding the standard deviation for the per-tile length, but we want to find the standard deviation for per-tile length and then group it by the species, okay? So let us say, I will name that I will assign it to, let's say, standard deviation of per-tile, okay, let's say per-tile length, per-tile.length. That's the name I'm giving it, okay? And then per-tile.length for species, okay? For each of the species of the iris data, okay? So now, so this is the name I'm giving it. So I'm going to use a function which is called the tapply or apply, whichever way you want to call it, okay? So now we say the tapply function, okay? Now, once you use the tapply function, we have to be able to first of all get our vector, which variable are we looking at finding or computing the standard deviation on, okay? So we say the per-tile length, so per-tile, so we say we have the per-tile dot length, okay? Yes. Okay, which is the variable. We want to use this per-tile dot length. And then what is the index, okay? So the index over here is actually asking you which categorical variable are you actually looking at getting the per-tile, the standard deviation of the per-tile length for each of them. So we are looking at the species, okay? And then what is the function? The function, we say we want to look at the standard deviation, okay? Now let us go ahead and then run it. Okay, so now once we have run, we can be able to print out SD underscore per-tile length species. Let's run that line. Okay, so now it's able to give us, so this is the standard deviation for all the species for per-tile length, okay? So if you take per-tile length, for Setosa, the standard deviation for Setosa for per-tile length is what, 0.17. For vesicular is what, 0.48, and then for Virginica is 0.57. Okay, so this is how you can actually use the T apply to be able to actually compete. Okay, now subsequently we can decide to also find it, for instance, also find the mean. Okay, we can find the mean. So let me change this one to mean, because mean, but everything remains the same, but the function have to change. The function is now the what? The mean function. Okay, so now I can go ahead and then now I can highlight on this and then run only that variable to be able. So these are the means for each of the species for of what? Per talent. Okay, so now we also have what is called a description using the aggregate. Okay, so you can actually use the aggregate to be able to get, several description statistics, okay, for the species. So in other words, let's say you would want to get the descriptive, let's say the mean for petal length, sepal length, sepal weight, all the continuous variables of the data set for each of the species, okay? So you can use what is called the aggregate function. So let us first of all, let us look at using this aggregate function. Now what we can actually do is to be able to now use our clean iris data, and then now we can go into the clean iris data, okay? And then what we can actually do is we can put comma over here. But the question now we have to address in this is, what variables are we interested in finding the mean for each of the the mean for the species, okay? So now over here, what you can do, so we use the concatenate function, and then we are going to, remember I said we are going to look at it for each of the, which is the sepal length, the sepal width, the petal length, and then the petal width. And then now we'll be able to perform the mean for each of the species, okay? So now we can use the quotation marks, and then we can call the sepal, okay, so sepal dot length. Okay, then comma. Okay, let me just get copy over here and then just to make it quick. Okay, so let me put the quotations around each of them. Okay, comma. And then I have here the petal length. And then I have, okay, so let me put the comma, and then I have here the petal. Okay, all right. So now there's what I have. So next, what I'm going to actually do is to put here comma. Okay, so now what I'm saying is within the iris data, these are actually the columns I'm interested in competing. And what am I interested in competing? I want to compete the mean, but first of all, I have to be able to know the list. So you have what's called the by list, okay? List of what? So I want to look at it from the species, okay, for each of the species. Okay, and then now I can say which function am I looking at computing, which is the mean function, okay? And then I want to also ignore if there is any, I can use the .NARN, which will be able to still compute the function even if there is any, okay? Okay. So let's go ahead and run this. Okay. So now here we have, so you have for each of the species, we are now able to get the mean for each of the species under each of the continuous variable, okay? So for instance, it gives us for sepal length, these are the means. The mean for setosa is 5.03, the vesicular is 5.9, the genica is 6.6. Now, when it comes to sepal weight, it gives you all the means for the different categories of the species. Okay. So then finally, we also have another function in which we can actually utilize to be able to also get several statistical summaries, okay? So in that function, we're actually going to use, it's called the stat.desc function, okay? And to be able to use that function, you have to first of all install this package, and then now you can activate the package, okay? You have already installed the package, so I just have to activate it. So once I've activated it, what I'm going to do is I'm going to, let's say, call some value, let's say RS, okay, RS, and then this is what I'm actually assigning it to. Then the function is start.dex, okay? So now I can call my data set, iris.cleanData, and then I'm going to perform this on all the continuous variable except the fifth column, which is the species, because the species is categorical, okay? So now I can run this one. Now to see the statistical summary, I can actually, you can go ahead and then print out this, and then you'll be able to see, so there's the different statistical summaries you can get for each of the continuous variable, which is the 4 different continuous variables we have, right? But you can also reduce the decimal place to, let's say, 2 decimal place, okay? By just using what is called the run function. So run what? Run as the rest to what? To 2 decimal place. Okay, so that allow you to be able to run everything to 2 decimal place rather than having several decimals. Okay, so there is just a quick statistical summary you can actually perform for continuous variable, and then also you can also perform it for when you have each for categorical, find the continuous summary for each categories within a particular categorical variables. Okay, all right, so I will see you on another presentation which has to do with performing descriptive for categorical variables.